Welcome to section 7.1, applying exponent properties involving products. Now, the first property we're going to talk about is the product of powers property. And this happens when we are multiplying two terms together that have the same base. So in this case, we have a base of a and a base of a, and we're multiplying them together. Well, a squared, this first part, is the same as just a times a. And a cubed, that second part, is a times a times a. Well, when we're multiplying that together, that's the same as multiplying a together 1, 2, 3, 4, 5 times. So this is actually the same as a to the fifth. So if we wanted to take a step back and just come up with a sort of general equation we could use, since we started with an a squared times a to the third, and we ended with an a to the fifth, we can get there by just adding together our 2 plus 3. So that is actually the product of powers property, is when you're multiplying two numbers together with the same base, it's the same as if you just add their exponents together. So let's go and just try that a few times. So a to the m times a to the n, well, it has the same base of a, so you just have to add their exponents together. So it's going to be a to the m plus n power. Or with fives, we have a base of 5. One has a power of 6, the other has a power of 3. We add our powers together, so we get 6 plus 3 makes 9. So our answer would be 5 to the 9th. So let's go and simplify some problems now. So 7 to the 3rd times 7 to the 5th, they both have the same base of 7. We add their exponents together and come out with 7 to the 8th. And I am completely content if you want to leave it as 7 to the 8th as your answer on your homework. The book sometimes goes and evaluates this and actually has you do it on your calculator. I am just fine if you leave it as 7 to the 8th, but you do whatever you would like to do with that. This next one, we have a 9 to the 1st, because remember, if there's no exponent there, it's automatically to the 1st. So 9 to the 1st times 9 to the 8th times 9 squared. Well, we can add all three of our exponents together to get a 9 to the 11th power. Now this next one, we have negative 5 to the 1st times negative 5 to the 6th. Well, that's going to give us a negative 5 to the 7th. The one after that, and the last one working with this property, x to the 4th times x to the 3rd, keep the same base of x, add your powers together, we get an x to the 7th. So the next property that we're going to work with is the power of a power property. And this is a property that you get when you have a number that's being raised to a power, and then you raise that to another power. So in this case, a squared to the 3rd power means that we're multiplying a squared together 3 times. Well, that essentially means that it can be broken into our first a squared, which is just a times a, times our second a squared, which is another a times a, times our third a squared, which is just another a times a. So this is actually the same as a to the power of 1, 2, 3, 4, 5, 6. So it's the same as the a to the power of 6. So how can we get to 6 from where we originally started? Well, if we look at our powers here, if we multiplied those together, 2 times 3 would get us to that 6. So that's actually going to be our more generalized property, is when you have the same base, when you have a base raised to a power, when you have a base raised to a power, and that is then raised to a power, you multiply those exponents. So when you have a to the m to the power of n, that's going to be the same as a to the m times n power. Or 3 to the 4th to the power of 2, that's going to be the same as 3 to the 16th. Oh no, sorry, not 3 to the 16th, because it should be 4 times 2, which would be 3 to the 8th. Let's try some more like this. So 2 to the 5th to the 3rd, same base, we just multiply our exponents, and we get 2 to the 15th. Or we could have negative 6 to the power of 2 to the power of 5. Well, 2 times 5, that's going to give us a power of 10. Or our base could be x, and then it's a power of 2 to a power of 4. Multiply those together, 2 times 4 is 8. Or this last one, we have a y plus 2 to the power of 6 to the power of 2. 6 times 2 will give us a 12. And that's all the more we can do to simplify that. The last property we're going to work with is the power of a product property. And this property says that, hey, when you have two numbers multiplied together inside parentheses, and they're being raised to a power on the outside, well, what happens when that happens? So for example, AB to the third is the same as writing it out as AB times AB times AB. Well, since it's all multiplication, we can rearrange that multiplication any order we want. So we can multiply our three A's first, and then our three B's together. Well, A times A times A is the same as A to the third, and B times B times B is the same as B to the third. So in the end, what ends up happening is it's basically like we could just distribute that power of 3 into both parts. So since it was AB to the power of 3, that would be the same as A to the power of 3 times B to the power of 3. So let's go and use this with a few other examples. So AB to the M would be the same as A to the M times B to the M. The next one, this would be the same as 23 to the fifth times 17 to the fifth. And if you multiplied that out on your calculator and also tried it out as multiplying them first and then raising them to that power, you'd come up with the same answer. So that's kind of cool. Let's go and do some more like this. So 24 times 13, our power of 8 can go into both parts. So we'll get a 24 to the 8th times 13 to the 8th. This next one, our 2 can go into each part, which in this case is all three parts. So you could have a 9 squared, and then an x squared, and then a y squared. And if you wanted to, because you know that 9 squared is 81, you could simplify that. So you'd have an 81x squared y squared. Now for this next one, we have that squared goes into the -4 part and the z part. Well, -4 squared, that will give us a 16z squared. The reason I wanted to clarify in this case that it would be 16z squared is because the squared will end up getting rid of that negative. What's different than in this next example is the negative is on the outside. So when we bring our squared in, 4 squared will give us a positive 16, z squared will be z squared, and then that negative will come into play out in front because it multiplies in at the end, so we have a negative 16z squared. So even though our answers are similar, it's because the difference is because they were written using a different format. Final problem here. Let's go and distribute this power of 2 in. So we'll come up with a 2 squared times x to the third squared times x to the fourth. Well, x to the third squared, we can multiply those exponents. So we would then have an x to the sixth times x to the fourth, and still have that 2 squared out in front, which is the same as 4. Well, we can now simplify this because we have the same base to different powers, so we can just add those powers together. So we'll come up with a 4x to the 6 plus 4 is 10th. So 4x to the 10th power. So that's all the more I've got for you for today. So good luck, and let me know if you have any questions.